speech sentiment analysis. Suppose you work at a company where your task is to call up customers and convince them to buy your products. So simply you call up each potential customer, explain how your product works and why they need it, and then based on whether the customer thinks they need it, they buy it or not. Now suppose you made a call to a client. You explained what your product is, why it is needed, and the client is convinced. So he agrees to buy it. He then makes the payment to the company. And once the payment is complete, the products are shipped to the client. Soon they are delivered. After a while, you call the client again and ask for feedback or review of the products. The client says they were okay. You then ask if the client would like to place orders for more. The client says he will do so later. And then every time you try to reach the client, he doesn't take your call or says he is busy in a meeting or says that he doesn't require the products as of now. So, if the client liked the product as he said, why did the client not buy more of them? Focus on the word the client used to describe your word. Okay. The word means your client is fine with the product. But in reality, the client wasn't exactly satisfied. And there were a few things or features he found in your product which were absent or not functioning properly. However, he did not tell you about them since he thought that it was too much hassle. On the other end, you were thinking that the client liked the product and waited for more orders which never arrived. So simply the first problem with this method was that you could only hear the words the client said, but you did not understand the sentiments or actual feelings the client has toward your product. Secondly, you didn't interpret the voice of the client correctly and thus missed the hint that could have pointed you to the problem and helped you deal with it. Thirdly, because you missed the important feedback of the client, you couldn't improve your product and so missed the opportunity to earn back the client. For example, if you sell laptop chargers and your client buys some from you and finds them overheating too often, sometimes he won't reach out to you since he only bought a very small amount first for trial purposes and doesn't want to go through the hassle of explaining the problem and getting replacements when he can find some better chargers locally. So you missed a client because you didn't detect the actual feelings of the client. So he will give you a positive or decent review, but he won't exactly mean it. The way you can deal with this problem is by using sentiment analysis. Sentiment analysis analyzes the word and tone of the customer and understands how the customer is actually feeling. Using this, you can understand when the customer said okay, he didn't mean okay, but rather that he was unimpressed or that there were some problems that he had noticed in your products. There are three main sentiments. There are three main types of sentiments: positive, neutral, and negative. Negative sentiments include fear, anger, disgust. Neutral emotion is like there's no category, there's just neutral, emotionless. And positive are happy, excited, you know. So while humans can detect positive or negative sentiments easily, humans find it difficult to identify neutral or unimpressed feedback and discern it from positive feedback, because the words used in neutral feedback are usually okay, which could also be used in positive feedback. So many times humans mistake neutral feedback for either positive or sometimes for negative. So this results in misinterpretation and loss of customers over time. But using sentiment analysis, this problem will be solved as the machine will be trained to identify how the client is feeling based on the voice and words of the client, just like a human but more accurately. And it will also constantly be doing sentiment analysis Humans focus on the tone for a while, but you will realize that even you on a phone call after a while start focusing on the words. So if you have a sentiment analysis model which can identify the emotions of the client, you can adjust your questions accordingly and get to the root of the problem. You can understand why the client isn't satisfied and deal with the problem by reducing the by dealing or reducing or removing the problem from your product. Because of this, you will face less complaints, and over time your product will have established a good reputation. So in the same scenario, after you have shipped the products to your client and he has received them, some time passes and you call the client to get feedback. This time too, the client says okay. But now using sentiment analysis model, you know that the client is not satisfied. So you ask the client what problem or issues they have faced. You've asked questions to find out why is the client not happy. Once asked, the client will tell you the issues that he faced, upon which you can deal with the problem, in this case the overheating problem, and send the client a new batch of chargers, for whom the client will have to pay only if they aren't overheating. The client, finding the heating issues addressed, will buy the chargers from you, thus you will make profit and more clients. We will be classifying the RAVDES dataset, which means the Ryerson Audio Visual Database of Emotional Speech and Song. So RAVDESS. This dataset has 7,356 files rated by 247 individuals, 10 times on the emotional validity. The entire dataset is 24.8 GB, but we will be using a smaller compressed version. In the dataset, there are 24 professional actors who have recorded different sentences which are capturing different emotions. For example, the following image shows some of the data. In the name of these images, you will notice they're given in a strange way. These are not dates because there are 7, if I'm not wrong. Are there 7? Yeah, there are 7 values. So what are these values meaning? The first digit is modality. Simply it tells you whether this file has audio and video, or it has only video, or it is only audio. Second digit tells you whether it's speech or song. Third digit will give you which emotion it is. Fourth digit will tell you the intensity of the emotion. Neutral emotion does not have any intensity, does not have strong intensity because it is neutral. Fifth digit tells you, so there are 2 statements which are used, and fifth digit tells you which statement is being used. Sixth digit is the actor number. So there are 24 actors, so they are assigned numbers 1 to 24. Odd numbered actors are male, even numbered actors are female. So in the screen here you can see the first recording was by actor 1, which is an odd number, so it was a male. The second recording was by actor 2, so it means it was a female, right? And you can also see that the last 3 audios had neutral, a calm emotion, while the first 4 had a neutral emotion. So like this, there are many audios available. So these are all the target variables. We will be trying to predict, in our case, emotion, but someone can train the sentiment analysis model to identify whether it's a male or a female, or whether the person is singing or talking. But we are focusing mainly on the emotion. So our emotion is the target variable. We will be using Librosa module to get the features or audio statistics of our data. There are several statistics like MFCC, MEL, etc. By using these values, these variables, and verifying them against the results, the machine can understand which values represent which emotions. We will also be using MLP, which is simply artificial neural networks rather than logistic regression. Logistic regression cannot capture complex relations between multiple features in without using a lot of time and being very slow. So it requires a lot of power. So instead, and despite that, its accuracy is not good enough. So instead, we will use MLP or multi-layer perceptron, which will capture the relation of each variable to the target variable in an accurate manner and optimize which variables have more impact on our target. It will also find the error and adjust itself accordingly. Here I have given an overview of how our machine learning model will work. First, we will get audio data, extract the audio features using Librosa library, split data into train and test sets. The machine learning model will study on the training set, and then after identifying the patterns in the data, will test its prediction on the testing set. Our train set size is 75% and our test size is 25%. We will then give the results to an MLP classifier, which will have an accuracy of 75%. So Librosa. Our Librosa function will first get audio file names in which the emotions are the third digit. So we will separate that, we will get all the third digit from the file names and store them in a separate column. The emotions are numerically encoded. 1 is neutral, 2 is calm, 3 is happy, 4 is sad, 5 is angry, 6 is fearful, 7 is disgust, 8 is surprised. After this, we will use the Librosa library to extract the statistics of the audio. Simply different statistics that you have in audio like MFCC, MEL. Audio technicians can understand what the exact meaning behind the terms are, but we don't need to go that deep. So we will just focus on getting the results from the statistics rather than on the statistics themselves. Then we will split the resulting array into 7 parts and take averages of features. So once you have taken all the results, as they are numerical values, they will be given in an array. So you will have all these values for every audio, and there will be a list of numbers, right? So you will split this. So because for every second you will have a different statistic, the statistics will change. You will split them into 7 parts. And that is because if we take statistics of every single second, like in this case, if we take our statistics too frequently, our data will be very inconsistent, right? Because you're focusing too much. We need to show the pattern of the data over a course of some time. So we are splitting our audio files in 7 parts, thus showing the values in different parts so our machine can understand. So if you try to compute the statistics for every second, first of all there will be too much data for the machine to handle, and the machine cannot handle so many different variables over every single second, and the patterns over time will get obscured. The machine cannot remember so many variables or features, and it will start forgetting, and the patterns in the data will become unclear because there will be just so much to process. So that the machine can identify the patterns, we will split this data into 7 parts. This is a neural network. The circles in this network are known as neurons or cells. The neurons, which are colored light blue, are the input layer. The gray neurons are the hidden layer, and the green neuron is the output layer. The way a neural network works is that it takes some input, passes it to a neuron, which creates a function. This function compares the variables or our x, which is simply all the variables we are using to predict our y, with the y. So it takes our x, compares it with our y, and finds for how much change in x is y changing. Once it has created this equation, it makes some predictions. If its prediction based on that equation is wrong, it adjusts the equation based on the error. So because it does not want error, right? What is error? Error is simply how wrong was your prediction, right? So we don't want error. We want our error to be very less, as less as possible. So it will adjust the equation so that there is less error. Now every neuron has a different equation. Every neuron makes a different equation based on the x. Some equations are better than others and are given more influence over the output. So if one neuron is performing very well, like 90% accuracy, then it is given more influence over the output. It is given more power to change the output. And it keeps doing this until the neural network has a high accuracy. A network is made of two parts, the linear part and the sigmoid part. So to give an example which can clearly show how the neural network works, let's take a house price prediction data. Here there is a variable on the basis of whom we will try to predict the house price. Now what a neuron will do is it will take all the data points of this variable, area and square feet, and try to find a line that fits the data points the best. This part of the neuron, so there are simply two parts of the neuron. There's a linear part and a sigmoid part. So in the linear part, it will take these variable, all the data points of this variable, area and square feet, and try to fit a line that fits the data points the best. So to find this line, it will use the equation of a line, y equals mx plus c. So here y is our target or dependent variable. So in our case it's price. M is the slope of the line, which is simply the value by which x affects y. So how much for a change in x is y being affected. So if your slope is less, so it will simply mean that a change in x is changing y very slowly, so your line will be more gradual. But if your slope is higher, it means that x is affecting y more strongly, so your line will be very sharp. So that is m, which is the slope of the line. X is our x variable or independent variable, which means they are the variables we will use to predict y. Y is dependent on x because our predictions of y will be dependent on our x. But x is independent because we are not using anything to predict x. C is our y-intercept, simply the value of y when x is 0. In our case, the value of y when x is 0 is also 0 because a house with 0 area will have 0 price. So it does so to create several equations. So every equation generates a different line and it checks the errors for every line, every possible line. So instead of drawing the line like I have currently drawn it, you could draw it higher or lower or sharper or slower in its rise, or you could make a line which goes the opposite way, downwards, right? So it checks the error for each possible line and finds which line has the least error. So how is error calculated? Now there are many methods. So first is mean absolute error. So error is simply calculated by subtracting the actual values by the predicted values. So for example, we predicted our price in the first data point to be, so this first data point here, so we predicted it to be 58 lakhs, but our actual value is 60 lakhs. So our error will be equal to 60 minus 58, which is equals to minus 2. Linear regression adds up the squared errors, takes the average, and that is the MSE or mean squared equation error of your line. So mean absolute error in this case, where you have an error of plus 5 minus 5, will say, okay, first let's add up the error. So plus 5 minus 5 equals 0. So what is the mean of 0 over so many data points? I think there are 9 data points, so it's 0. Your error is 0. But our model has made error, 5 on the upper side and 5 on the lower side. Mean squared error simply says, okay, so what are our error? Plus 5 and minus 5. So minus 5 squared plus 5 squared is equals to 25 plus 25. So your error is 50. This prevents from positive errors and negative errors cancelling each other out and resulting into an imperfect model having better accuracy than it deserves. However, there is a problem with this approach. So this thing that is displayed here is the slope table. Simply it's every possible equation, every possible value of slope and intercept, which will simply change our line, because our values of x and y are going to be similar, the same, right? Because your x value isn't going to change and your y predictions will change but they will change based on your intercept and slope. So these are all the some possible values of intercept and slope and their error. So our linear regression will create this table and see which possible intercept and slope has the lowest error. So intercept 0 and slope 1.6 has an error of 0.08. So it is the best fit, and it will select this line. However, there is a problem with this approach. If there is a data set like follows, like in this case we are predicting whether a person bought house insurance or not. Anywhere the line is at, the blue line is at less than 0.5, the prediction is negative. So because there is a low chance that the person will buy house insurance, it's less than 50%. So that means the person will not buy house insurance, so it is 0. And in this case we are misclassifying 5 points. Instead, if we use this model, we will only misclassify 3 times. This also prevents from a new outlier changing the model. In this case, if a very old person took the insurance, or 2 or 3 old people took the insurance, the model, in trying to fit that person to the line without making error, not without making error, but to decrease the error, because even if it predicts some 70-year-old to buy the insurance, it will predict it to be approximately 90%. So the model will say that's still 10% error. So it will try to adjust by taking the line higher. Now what will happen because of trying to make the line higher or increasing the slope is that some data points which are previously classified as ones will be classified as zeros. Like you can see this data point very close to the vertical black line. When the slope will increase, what will happen is the probability of this person buying the insurance will decrease. Like it's now just more than 50%, but if the line tries to fit that data point and lowers the slope, it won't increase the slope, it will lower the slope. So what will happen because of that is this point will get misclassified. So how do we get this line, which cannot be shaken by outliers and has better accuracy? By knowing where the major trend in the data is shifting. In this case, after 35 years old, a lot of people are willing to buy the insurance. So this is a major data shift, trend shift. Linear regression is dealing with the whole problem like there is a linear solution. So 30-year-olds, so the difference between 20 and 30-year-olds is almost same to the one between 30 and 40-year-olds, which is the same as 40 and 50. But that's not the way it works. Once you reach 35, your inclination to take life insurance for those you care for increases. So we will be using something known as sigmoid function. Sigmoid function converts all predictions to values between 1 and 0. So simply it will take any value and return a new transformed value which will be between 0 and 1. So how does it achieve this? It takes the output of our first line equation, which was y equals mx plus c. And wait a second. So it does so using a formula. Y equals 1 upon 1 plus e raised to minus y. And in this case, e is Euler's number, which is 2.71. So what it does, it takes our equation of a line, which is y equals mx plus c, and then applies, and then on the output of our y, so for example our slope is 0.04 and our y-intercept is minus 1.53. So using this, it will get our y equals mx plus c. And suppose we are doing it for the life insurance problem, and we are doing it for someone with age 80. So it will say, okay, 0.04, which is our m into x, which is 80, plus c, which is minus 1.53, and we'll get the value 1.67. So this is above 1. So it is simply saying the possibility of someone buying this insurance is much more than 1. This is the problem which makes the line try to lower and adjust itself. So how sigmoid function deals with this is it takes this 1.67 and says y equals 1 upon 1 plus e raised to minus 1.67. So e being 2.71, so it becomes 1 upon 1 plus 2.71 raised to minus 1.67, which is 0.96. So it converted this value which was above 1 to the range between 0 and 1. So this is what happens in every single neuron, and then based on which neuron is better at predicting the target variable, which neuron has found the best fitting line, each neuron will be multiplied by a weight to either reduce or increase its impact on the final prediction. If the neuron is good at prediction, it will get a higher weight. The highest weight possible is 1 and the lowest weight possible is 0. If the neuron gets a high weight, or if it gets 1 as a weight, its prediction will have full impact on the output. If the weight is 0, the neuron's prediction will be multiplied by 0 and will turn into 0, and so it will have no effect on the output. Now let's get into the programming part of our project. Here we are just importing necessary libraries. So what are libraries? Let me explain. Libraries are this when you want to call a huge block of code and you don't want to code the entire thing. So for example, for importing necessary libraries simply consist large blocks of code which are given names through which you can call them. Earlier there were no libraries and you had to manually code everything yourself. For example, if you don't know the name of a person and want to talk about him to a friend, you will have to ask your friend the guy's name by giving a list of his features, how he looks, what he wears, where you met him, etc. And then your friend will recognize the guy you're talking about and give you the name. When you start using the name, you no longer need to describe the person. You can just use that one word name and your friend's mind will automatically conjure the guy's image or will show the guy who you're talking about. So your friend will know who you're talking about. Similarly, when using libraries, you don't need to type in the whole code. You can just call the code from the library and use it. So here we are importing Librosa sound file, which we are going to use for audio statistics, right? Train test split and MLP classifier. So we are importing a lot of stuff from sklearn. It is a very important machine learning library. It has a lot of important machine learning algorithms like train test split, which are used on almost every project. NumPy is for math, so addition, subtraction, mean, median, mode, all that is from NumPy. Librosa is for audio, as I explained. So we are importing. Now we are creating an extract feature function. So we are using extract features so that our file can be, so that features can be derived from the file, like MFCC, Chroma, MEL. We want to derive all these features from the file. So for that, our file will have to be read into a new format. So first we say with sound file dot sound file file name. So we are simply reading the file name and converting it, and we are reading it into a new data type, which is float32, which simply means numbers with decimal places. Then we are declaring a sample rate. Sample rate is simply, as I explained before, the number of partitions it will make of the data. Then we are saying we are converting our results into an NP array, NumPy array. Array is simply a list of numbers. Then we are taking our MFCC values, which will be, there will be several of them, but based on the sample rate, we want to take averages. So for example, we decided, okay, every 7 seconds we will take a sample. So from the first 7 seconds, we will take all the MFCC values of every second and get the mean, and that will be the MFCC of that particular sample, right? Same for Chroma and MEL. After this, we are returning the result. Data pre-processing refers to the cleaning and transformation. So here we are simply saying what are the emotions that we are dealing with. So this is the list, so that our model can understand the target variable, which is the variable we are trying to predict. And then we are saying observed emotions equals calm, happy, fearful, disgust. We are going to be dealing with these four variables. Then we are defining our load data. So we are saying our test size is going to be 25%. We are declaring our x and y arrays, and then we are saying for file in data. So this is the whichever column you have stored it in. So we are saying for every file in our RAVDSS data folder, take every possible actor with whatever name or whatever numbers it has next. Take every file which starts with the word actor, which will be all the files, and read them one by one. Okay, and take and create an emotion variable. So where is the emotion variable? It is after the second dash split. As I explained earlier, the third digit is where the emotion is stored, which emotion it is. So we want that, right? If the emotion is not in the observed emotions, if it is not calm, happy, fearful, or disgust, or it is the other variables like angry, sad, neutral, discard them, don't take them. Okay, then we are extracting the features. This extract function that we defined earlier, this extract function, we are simply running this extract function on the file and getting the MFCC, chroma, and mel. So we have given true, true, true. We want all these three values. And then we are creating and then we are saying, okay, so now the feature, which is simply all the features, MFCC, chroma, and mel, send that to x, and in y send the emotion. Then we are declaring x test, x train, y test, and keeping our test size 25%. The reason this step is so important is our model will look at the training data. In the training data, it will have the emotion and the features given to it. It will observe what is the relation between the emotions and the features. So how much a change in one feature is affecting the emotion, how much change in the other feature is affecting the emotion, and will make an equation. So it will study the data and establish a pattern. In the testing data, it will only be given the features, and it will have to predict the emotion. And then on the basis, if it is and then it will, once it has made a prediction, it will get to see the emotion, which is the answer. And then on the basis of whether it is right or wrong, it will adjust itself. Just like us, when we go to a school, first we are given the answers and questions together so we can study. Then we go to give the test paper, and when we go to give the test paper, we have only the questions. We have to write the answers, and then someone else will check them for us and tell us how right or how wrong we were. Here we are declaring our MLP classifier. Our batch size is 256, so we'll be taking 256 records at one time. And the maximum number of, you can see here I've given a command max iter. Simply is the maximum number of iterations our model can take to reach the lowest error possible. In our case, it's 500. Then we are fitting our model on our training data. After that, we are getting predictions from our on the test data, calculating our accuracy and printing it so that we can see. It will be around 75%. So overall, we have dealt with all four challenges. The first challenge, that we only heard what the client said but couldn't understand how the client actually felt, was solved by artificial neural networks, or MLP classifier, which its full form is multi-layer perceptron. We didn't know which terms to look for or how to interpret the voice of the client, was solved by Librosa, which can extract the features from the audio and then interpret them. Without the proper feedback, we couldn't make any improvements, and so the client didn't make any new orders, was solved by sentiment analysis, due to which we can now ask the right questions and get the proper feedback. And the client either didn't have the time or didn't want to go into the problems of your product and just decided not to buy from you again, was solved also by sentiment analysis, because once you have found out the problems in your product and dealt with them, the client will obviously, even if you miss one client, the other clients will not face that problem and your sales will increase.